Let's talk about factoring a little bit. If you have two terms and both of those terms are perfect squares and it's a subtraction problem, that's called the difference of two squares. And a perfect square is a number that there's something else times itself that equals that number. So for example, 1 is a perfect square because 1 times 1 equals 1. 4 is a perfect square because 2 times 2 equals 4. 9 is a perfect square because 3 times 3 is 9. So those are perfect squares. Notice this is also a perfect square because 8x times 8x is 64x squared. So once I determine that they're both perfect squares and it's a subtraction problem and it's just two terms, I put down two sets of parentheses like this. In the first blank, I'm going to put down what is it times itself that equals 64x squared. And that's 8x times 8x. In the second blank, I'm going to put down what is it times itself that equals 1, and that's 1 times 1. And then one of these gets an addition sign and one gets a subtraction sign, and that is how you factor 64x squared minus 1. It's called a difference of squares, a difference of squares. It's a difference, it's subtraction of two perfect squares. So that's that. Over here, notice this is not two terms. This is not a difference of squares because for a lot of reasons. We don't have a difference and we don't have two perfect squares. Instead, we have four terms. Usually in high school, when you have four terms, that is going to be done by using the grouping method. And the grouping method is named appropriately because what you do is you just simply group the four terms into two sets of two here. So I'm grouping the first two and I'm grouping the second two. It's called factoring by grouping. And then you factor out the greatest common factor in each group. So notice in these two, they both have at least an x squared. So that's my greatest common factor. I'm going to factor that out. And this becomes x plus 64. So it looks like that. Oops, 64. Where did I get 64? 6. This was 6x squared. Sorry. So this becomes a 6. Let me rewrite this. So not 64, I don't know where that came from, but I just grouped these two together here and then those two together there, and that's a 6, not 64, but x squared is the greatest common factor, so it looks like this. And then I come over here and I factor out the greatest common factor over here, and the greatest common factor between those two is an 8. And so it looks like this. Now notice that this part is the same in each one, and I want that to happen. In fact, if that didn't happen, I would know I made a mistake, or perhaps it doesn't factor by grouping after all, but these should match up. And the other thing that could happen is maybe I need to rearrange these numbers up here and put them in different groups. But this is a good sign. It means so far so good. So what I do is I put that common term in one set of parentheses by itself, and then I'm going to have another set of parentheses. I can even mark through this, and then I can clearly see what's left over here is what's going to go here. So I've got the x squared and the 8 that goes in the next set of parentheses, and that is called factored form for this problem up here. And I did it by grouping. I grouped the first two together, I grouped the second two together, and I just factored out the greatest common factor in each group. And this is the factorization. So that is how you factor two different types of problems. So the first type is a difference of squares. That's what that looks like. And the next one has four terms, and we did it by grouping. Let's see if I can spell grouping here, looking through my phone. Okay, yeah, grouping and difference of squares. So ponder that. Difference of squares, grouping. Make a note of that. See ya.